So there I was, facing the same exact problems. I couldn't do multiplication, addition, subtraction. Who was I? Friends, they came to help me, but just as quickly as they came, they left. It was all getting so frustrating. I didn't know what to do. I was lost. And then it hit me. Why don't I just make a machine to do it? Hello, hi, how are you? Welcome to the first video on the channel. My name is Andrew Neg, and you've already seen the intro, so you know what we're doing today. That's right, so I made a machine to do my math homework. But before we can see it in action, we're gonna have to take a couple steps back to see how it works. And, to admire the flawless engineering process. Just kidding, there were a lot of flaws. And I mean a lot of flaws. So the first part of the build is mechanical. How is the machine able to physically move through space to actually draw our answers back onto a piece of paper? But for that, I'm gonna have to take you from the beginning. First, I had to 3D print some parts. What were the physical structures that were actually gonna be part of the machine? I printed this on my Ender 3 3D printer. Next, I gathered some more parts and assembled the machine. It consisted of 2 stepper motors with a belt and a carriage that included pulleys and bearings. With a pen for drawing and a couple of screws, we had a machine that could now draw. This design was created by Henry Arnold, and the link to his Thingiverse page will be in the description.
Alright, so I want you to imagine that each of these M's mean one motor. So basically whenever these motors turn, this whole carriage is going to be able to go left, right, up, or down. This is where the pen is, and this is essentially the back. So if both motors are moving right, then the carriage along with the pen also moves right. Both motors are moving to the left, then the carriage will move to the left as well. Both motors are moving in the same direction, it moves in the x-axis. But what's very interesting is that when both motors are moving in opposite directions, it actually causes the carriage to move in the y-axis due to the way the pulleys are set up. So in this case, it's going downwards, and in this case, it's moving upward. So to put this in perspective, I can show you a little demo. When both motors move towards the left, essentially the carriage are moving towards the left. When they both move to the right, it moves to the right. When they move in opposite directions inward, it actually backs up the carriage. And when it moves forward, it's able to move the pen forward as well. Then, using a stepper motor, it's able to lift the pen up or down. And with this, we were able to draw a Minnie Mouse, but we're gonna need a lot more than Minnie Mouse. So the next part of this was programming. How is the machine able to look at a piece of paper, find where the equations are, what each character means, and then solve for it? So I had 2 options, one of them being PyTesseract, a pre-built library that's able to read characters. First of all, it was easy to use. Secondly, it was extremely accurate. Third, it only required 3 lines of code. Fourth, it basically required no debugging from my end. 5, it had a lot of information online. 6, it was able to read a large variety of text. What can I say? I had a point. So I went to the internet and I found if I wanted to make my own character recognition software, I needed to use neural networks. And honestly, they didn't seem so bad. Needless to say, I wasn't about to give up. So I spent the next 3 weeks and filled a book of equations, and then I threw it up on the wall.
Those 3 weeks were spent understanding the theory and the application behind neural networks. And once I got my head around it and how the equations come into play, it wasn't that bad. As I said before, it's not too difficult to understand. Let me explain it to you.
A neural network takes in input data, which is then passed through a list of theta values that change. When it reaches the end, it outputs an answer, then checks it with the actual answer to see how right it was, and then goes back and changes those theta values. It does this back and forth until it can predict unknown data. This machine uses 3 networks, one to detect where the text is, another to separate characters, and one more to find out what character of the text is. After the equation locations and characters are found, it then solves and outputs on screen.
So now I had to go from a theory to an actual prototype.
Yeah, this part of the build was not fun. Like, at all. Alright, well, this is kind of annoying. What do you mean it doesn't work? You're literally... I literally Googled a question that this has nothing to do with this.
I may have gone a little crazy.
You're gonna work, right? You're gonna work, and I don't know how you're gonna do it. But when I did get it, it was the best feeling in the world.
So basically, after a month of programming, I had well over 1,000 lines of code. And when I finally got it to work, this happened.
Oh god. Oh yeah. It works. It works. It works. It works! Oh my god, it works. Oh, finally. We did it. Oh my god. Yes, we did it. Oh! Yeah! We did it! Finally! Oh my god, it took so long. Oh jeez. We did it. We did it. It's right there. Oh my god, the camera. It's right there. Oh, take a look. Take a look at this. Okay. Oh, we did it. Oh my god. We got actual text output. Text output. There we go. Self-made neural network. Text output, baby. So I had to go from that output on there, which is from my computer, to this thing, which is called a Raspberry Pi. And think of it as that thing, but tinier. So a microcomputer.
The Raspberry Pi with the stepper motors, it required an additional hat, which I then soldered. All that was left is to integrate the Raspberry Pi camera and load the code onto it.
So now I hear you saying, wow, Sandish, you did all this complicated math to make a machine that does first grader homework. You know what I say to that? There's a part 2. That's right, there will be a part 2 coming up where I integrate the photomath app that is able to do everything up to differential calculus, I'm pretty sure, and integrate that into the machine. But don't expect that too soon. I am kind of sick of this project, you know? It was meant for literally only a week. I took 2 months. Hello, Future Sandish here. I just finished editing the video and I just wanted to say thank you so much for watching. I spent a lot of time on this, and I really do hope you enjoyed. Sorry there wasn't a lot of footage, because I really didn't think this was going to work out in the first place. But if you stick around, there will be a lot more projects that are cooler than that one. So, again, thank you so much for watching, and I will see you in the next video.